Hello everybody. Hello and welcome to Psych with Mr. Parsons. I want to go over what you're going to see on the Unit 3 test. I'm currently out of town, and so I wanted to give you a chance to review before you took the test. So we're going to learn a little bit about memory, or talk about it today. No, we're not going to play the game memory, although that would be fun. It's a fun game. But we're going to talk about some of the things you learned about how to make your memory work. So there's a couple of things we can do to help us remember things, to put it in, and also to help it come out. Okay, one of those things is one of those useful things is a mnemonic. You can see on your screen here a couple of different mnemonics that you probably know that you've used throughout your life. In 1492, Columbus sailed the ocean blue. Helps us remember the date that Christopher Columbus landed here in the U.S. or in the Americas anyways. Every good boy does fine, EGBDF, the lines on the musical staff, and then of course we've got Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet, the colors of the rainbow. Those little tricks are mnemonics that help us understand, help us put the information in our brain and also get it back out again in a good manner. Now, we talked in this unit a little bit about some types of conditioning, how we can take our memories and try to create behaviors with memories. Operant conditioning is when we use rewards and punishments to encourage certain behaviors. Operant conditioning is focused all on rewards and punishments. It creates voluntary behaviors, and there's the key. Operant conditioning is when you've experienced operant conditioning, you experience voluntary behaviors. Okay? You choose to do that because you want the reward. As part of this system of operant conditioning, you have to come up with a ratio or a timing for when you're going to give that reward. And here are a couple of different examples, real life examples of these type of ratios. A fixed ratio would be like a punch card, a frequent shopper card. Fixed ratio means that every time you complete the behavior, you get the reward or punishment. In this case, it would be a reward. Every time you spend $10, you get a punch on your punch card. That's a fixed ratio, 1 to 1. Every time you do one, the other is going to happen. A variable ratio would be like a slot machine. Every time you pull down that handle, you're not necessarily going to get the reward. But occasionally you do, and you don't know when. That ratio changes often. Changes back and forth, so you don't know exactly when you're going to get that reward. That would be a variable ratio. You pull the arm, it doesn't work. You pull the arm, it doesn't work. You pull the arm, it works. Okay, you pull the arm, it doesn't work. You pull the arm, it works. Wait a minute, that's the second time. That's a variable ratio. A fixed interval, the time in between reinforcement, the time in between the reward or the punishment. A fixed interval would be like a payday. You know, every 2 days, or 2 weeks, sorry, you're going to get a payday, so you know that that's coming. Okay, the payday is set no matter what. It's an interval, it's a time period. Or a variable interval, a good example of that would be like a pop quiz, even though it's not really a reward, but you never know quite when it's going to happen. Those things happen whenever, okay? It doesn't have anything to do with the behavior. It has to do with the amount of time that has passed. Okay, so there's ways that you can manipulate those reinforcements to your advantage. Variable ratios, slot machines, are obviously very addictive, and you can help create behaviors that way. Now, as you're going through the steps of operant conditioning, we come across this step of extinction. Okay, extinction is when you have created this behavior and now you're trying to get rid of that behavior, or it goes away by itself. That's the extinction period. Sometimes after this extinction period, you'll notice that a behavior might spontaneously happen again. Let's take Pavlov's dogs, for instance. If he had caused them to salivate with stimulus other than the bell, so he did the bell thing, they salivated, and then he changes over to a different stimulus, how would that have affected, you know, that would have gone away. That would have been the extinction. If he rings a bell a month from now and a dog starts to salivate, that would be a spontaneous recovery. So the behavior had been extinct. It will then pick up strength that equals a spontaneous recovery. Now, we can use operant conditioning to our advantage. Actually, a scientist named Mary Cover Jones used operant conditioning to help a boy named Peter. Peter was afraid of things. He was afraid of furry things, and rabbits were scaring him to death. So what she did was every time she showed him the rabbit, she gave him candy. Eventually, when he would pet the rabbit, he would give her, or she would give him candy, and vice versa. So he started to associate this rabbit with good things, and eventually he was no longer afraid of the rabbit, and it became a good thing. So we can use operant conditioning to our advantage. It's not just to get rid of negative behaviors, it's also to make good things. Now, there's another type of conditioning we talked about, classical conditioning. A good example of classical conditioning would be, say, if you've ever gone to get a shot, the nurse uses this alcohol to swab your arm, and so now anytime you smell alcohol, you get anxious. This is an involuntary response. Being anxious is involuntary. So with operant conditioning, the response is voluntary. You choose to do the behavior because of the reward. Classical conditioning, it's involuntary. You get anxious and you feel, why am I anxious? Oh, maybe it's because the last time I smelled alcohol, I got a shot in the arm. That's no fun. As part of the process of classical conditioning, one of the side effects may be generalization. Maybe every time, let's say, you got stung by a bee when you were a kid, and so now you're afraid of all bugs, even though some bugs are not harmful and they're not going to hurt you. You're just afraid of bugs in general. You're generalizing that because a bee was a bug, that it's going to hurt you every time. That can sometimes happen with classical conditioning. So let's go through some of these, and this will be on your test. You'll have a chance to do some matching. What you'll see is a list kind of like this, and you have to put 2 and 2 together and find out which one is which. So let's look at, first off, our unconditioned stimulus and our unconditioned response, UCS. Those are behaviors that will happen naturally, okay? Unconditioned mean it happens naturally. Generalization, we just talked about that. That would be responding to a similar stimuli. So the bee thing, you got stung by a bee, and so now you're afraid of all flying bugs. Conditioned response, or conditioned stimulus and conditioned response right here, that would be learned behavior, things that we've learned. We have been conditioned to do that, so now it's learned. Acquisition is the time it takes to associate a neutral stimulus with an unconditioned stimulus. And then our discrimination is not responding to a similar stimulus. So in Pavlov's case, if he rang one bell to get them to salivate, if he rang a different kind of bell and they didn't salivate, then he could tell that there was discrimination between the two. Okay. Let's see if I can get out of writing on the screen. All right. Now let's move on to our next slide here. These two theories, operant conditioning and classical conditioning, the two kind of champions of these theories are B.F. Skinner. He really worked hard on the operant conditioning theory. He used his Skinner box down here with the mice. And again, operant conditioning usually produces voluntary behaviors. Classical conditioning was Ivan Pavlov and his dogs drooling into a cup experiment, which was classical conditioning, creating an involuntary response. Okay. Now let's talk a little bit about how memories make it into our brain. We talked about using memories to create behaviors. Now let's talk about how memories enter our brain. Typically what happens, the sequence for that, is things come into our sensory memory. Sight, sound, smell, taste, and touch. Those are icons that enter our sensory memory. Some of those things we just kick right out. We talked in class about, focusing on your big toe. before I said that, you didn't really know how your big toe felt. It was just getting kicked right out. But now that you're thinking about it, your big toe, that becomes part of your attentive memory and can make it into your short-term or working memory. It then becomes a bit of memory. Now sometimes those fall out. We don't think about it very long. If you don't think about what your big toe is doing for the next few minutes, you'll probably forget that we even had this conversation. It'll go right out of your short-term memory. You can hold about 5 to 9 bits of information in your short-term memory at a time. If you do some things like rehearse that, think about it over and over again, it will make it into your long-term memory. It becomes an engram. Once it's in your long-term memory, it's an engram. Later you can retrieve it, bring it back to your attention. This is kind of where we focus on our attention here in the short-term memory and working memory. Okay, so the sequence, it goes from an icon to a bit to an engram in your long-term memory. Now, as we're trying to remember things, we get into certain things can happen to us. So for a second, I want you to memorize this list. I'll give you a few more seconds. Okay, now write the list. Write it down on a piece of paper or something like that. Most of you are going to get the first couple words, dog, bark, maybe house, and the last few words, collar, run, and frisbee. Most of you are going to get those written down no problem. But those words in between, well, sometimes those are harder to memorize. This is due to what we call serial processing, not serial like C-E-R-E-A-L, serial as in order. You'll remember the things at the beginning and at the end most. Things at the beginning because of the primacy effect. It was the first thing, it made the first impression in your mind, and so that sticks. And the recency effect helps you remember the things at the end. It was the last thing that you just thought about, and so it's still fresh in your mind. All the stuff in the middle kind of gets jumbled up. So if you can think of it this way, here's a little mnemonic for you. I eat cereal for breakfast. I also eat it for dinner, and I can't remember what I had for lunch. The serial processing means that we kind of remember the things at the beginning and at the end more than we do in the middle. So when you go to study for a test, maybe you should study some of the stuff in the middle of your list more so than the things at the end. Sometimes when we try to recall things, we get stuck. We get to this tip of the tongue syndrome when it's just right there and we know exactly what we want to say. We can picture it in our heads, but the word just won't come. The tip of the tongue syndrome. We can avoid this, or we can treat this, is one way to say it, by priming. So if I were to tell you, we're thinking about an animal that curls up into a ball and rolls around, it's got a tough skin, what's it called, and you don't know what it's called, but if I say, okay, it starts with an A, and suddenly you go, oh yeah, armadillo. Okay, you just experienced the tip of the tongue syndrome, and I primed your memory. Okay, so sometimes we can help prime ourselves if we keep some mnemonic devices around for priming, like Roy G. Biv, R-O-Y-G-B-I-V. Red, orange, yellow, green, blue, indigo, violet. That's priming ourselves. With memory, there's certain gestalt laws that are associated with memory. Sometimes our brain is really good at filling in the blanks. The first gestalt law is closure. C-L-O-S-U-R-E. Your brain can fill in the blanks, and no. The second gestalt law is proximity. We might remember or we might think that these three are friends because they're sitting close together, even though they probably all hate each other's guts. So sometimes when we make memories, we're going to pull them out thanks to the things that we remembered with those things, or what was going on at the time. This idea of proximity. One memory can be close in proximity to another memory and help us recall those. If your girlfriend dumped you when you went to the movie theater, then when you go to the movie theater, you're going to remember that your girlfriend dumped you. Some of those proximity ideas. Our state of being can also affect our memory, our mood. When we're angry, we tend to remember things. Well, what happens sometimes is we can get angry When we're calm, we won't remember what happened when we were angry as well. So sometimes if we want to remember something that happened when we were angry, we need to get angry again. Smells can also very much influence our memory. How can we use this to our advantage? Well, if you're studying for a test and you know that you get anxious during tests, maybe you should be anxious while you study. That way, when you get into that situation, you'll remember things better. You at home, homeschool, we get this great advantage of creating our own smells. So try this sometime as a fun experiment. When you're studying psychology, put a certain scented candle or some sort of scent next to your computer while you're studying that. When you take that test, pull out that same scent, have it next to your test, have it next to your computer, and see what happens. Smell can actually influence our memories quite a bit. The reason being is, look where the part of your brain that deals with smell and the part of your brain that deals with memory and learning are. They're very close to each other. We've all experienced a smell that made us have a great memory. If I say pine needles, if you go in and smell pine needles, all of us are going to think, oh, Christmas time and cookies and grandma's house and stuff like that. So smell can influence our memories quite a bit. They're very close. So when this area, the smell area, is active electrically, it can kind of have an effect on this area of the brain that deals with memory and learning. Interesting, right? So there are certain types of memories. One type of memory that we know of is called an episodic memory. It's like one stimulus triggers a flood of memories. It's like I just said, Christmas, and suddenly you have 1,000 different memories of grandma and Christmas and what you got when you were 4 years old and things like that. Those are episodic memories. One little stimulus can trigger a flood. We also sometimes call these flashbulb memories, like, where you were exactly when something happened. And like, I remember where I was when I heard about 9/11. I was on the phone with a friend. I was actually in Singapore, and he says, what's on the TV, blah, blah, blah. And so I can remember everything in that instance, the flashbulb memory. It was one of those events that stick with you. Another type of memory is semantic memory. So most of you have learned what NaCl means. Doesn't have anything to do with what it actually is, right? These letters, they're kind of arbitrary, but NaCl, sodium, table salt, right? Rote memorization gets us to that point. That's how we learn language a lot. A lot of language is rote memorization. The word is means is because it does, and we just remember that, okay? Semantic memorization. Semantic actually means names, so this is name memorization. We also have procedural memories. Memories that help us do things. Do you still remember how to ride a bike? The saying goes, you don't ever forget how to ride a bike. It's something you can't forget because it's a procedural memory. Do you still remember how? How to do things are procedural memories. The process of things getting into our brain, to going from short-term to long-term memories, going to be able to make it into these types of memories, is what helps us do that is our hippocampus. It's an important part of the brain that helps us encode those memories, like we talked about earlier. To go from an icon to a bit to an engram, things have to go through hippocamp. Going through hippocamp is the way to get things into long-term memory. There's another mnemonic for you. If you can remember going through hippocamp is the long way, you'll remember that the hippocampus helps us create long-term memories. So that's your test. I do have a essay question on the test. You get to choose from one of these two. You've just gotten a phone number of a very interesting person. Now explain how you're going to encode that, and make sure you use the memory model, the icon, bit, and engram. Use those terms, and also some ways to help you remember that. Things like rehearsal. You say that number over and over again in your mind, or writing it down, or something like that. Santa, at this time of the year, is preparing for Christmas, and he's going over last year's list of all the good stuff he brought to the children of the world. As he's doing this, his helpers are talking about what the children want this year. Explain what memory errors could occur on Christmas and why that could happen. So here, we're talking about types of interference. Okay, interfering with old memories and interfering with how new memories are created. So you're looking for interference on that one. There is a game I'm throwing you a bone here. I like games. It is a Jeopardy game like we played last time. It is available on this website, jeopardylabs.com/play/psychology-unit-3-test-review. I know it's kind of a long one, but it was all it would let me do. So that is available for you to play, to review for this test. I hope things go well. Good luck.